Okay, question 4 was probably one of the hardest SUVAT questions I've seen. You really had to understand what was happening to the velocity, like as a vector as it moves on. So we know that the horizontal component of velocity never changes. So actually, as you move through each point, we're always still going to have 9i. We're always having 9i. That's not changing. But what is happening is that vertical component is slowing down. Gravity is pushing it downwards. So actually this would go down to 10j and then 8j. And then eventually up here, there would just be no... At that point there, that's when our... Remember, always that maximum point, is when our vertical velocity is 0. And then it would start increasing again. So to find the quote, to answer this question, it talks about the velocity of the ball at the instant it passes through A is lambda I minus j. So what that tells us is actually straight away we know that lambda is equal to 9 because that horizontal component never changes. And so then that tells us that my vertical component, my Vy, if you like, of the velocity is minus 9, and it started off as 12. So from there we can use that to find our h. So if you were to do a SUVAT here, I'm looking for h. I know it started off, and I'm going upwards here. It started off as 12 upwards. It's gone to minus 9. And my acceleration is minus g. I don't care about my t, so I know I'm going to use v squared equals u squared plus 2as. So I get minus 9 all squared equals 12 squared minus 2 times 9.8 times by h, which gives me a h value of 3.2. The question then asks you for the minimum speed. Well, think about what's happening to the overall speed. Remember, the speed is the magnitude of the velocity. It's the components of the vertical and horizontal put together. So here, the overall speed is 9 squared plus 12 squared, and it gets less and less. So the minimum speed is going to be here at that top point. So actually, the minimum speed for part B, this is why it was only worth 1 mark, is actually just 9. Because it would technically be 9i plus 0j, but obviously the magnitude of that is just 9 meters per second. The question then asks you to find the length of time for which the speed of the ball is less than 12. So if you didn't get that speed is the magnitude, really messed you up on this question, because actually we want our overall speed to be equal to 12. Well, we know that that horizontal component isn't ever going to change. So my vertical component, my Vy, if you like, my vertical component is just going to be equal to the square root of 12 squared minus 9 squared. Because it's saying that will give me the point in here where there'll be somewhere in here where when you add these two components together, you get a total of 144. And when I do that, I actually get a value out of root 63. So that tells me that my vertical component of the velocity is 63. So then from there, it doesn't, there's kind of lots of different ways. You're essentially looking for the difference between the times here to here. You could do that because you know that at one stage, the vertical velocity will be root 63 in the positive direction or minus root 63 vertically. Another way to do it is comparing it to the 0 and double it. I think that's what quite a few of us did, so maybe we'll do that this way to show you. So if I were to do another SUVAT, and I'm doing that between the first point, we get to the overall speed being 12, and then because remember the speed is going down as we move up, so we're going to want all the times in between that point. And then if I go up to the point where my vertical speed is 0, then I can just double that time. So if I do a SUVAT, I want to see when the velocity turns to 0, it starts off as root 63. My acceleration, I'm going upwards, is minus g, and the time is what I'm looking for this time, so I'm going to probably use v equals u plus at. So 0 equals root 63 minus 9.8t. When I do that, I get root 63 divided by 9.8. Gives me an answer for t of 0.8099. And actually that, like I said, was just this distance between here and here. So I then double it. So time equals 1.62 seconds. Another refinement of the model, things they accepted in the mark scheme were the dimensions of the ball, the fact that the ball could be spinning, the effect of wind. Any of those would have given you that mark there. Hope that's helpful.